Okay, the evidence we'll look at tonight, just to give an overview so you know where these different topics fit in. We'll look at the soft tissue that is being found in dinosaur bones. Dinosaur bones have always thought to be completely mineralized. None of the original biological materials left there, just stone and that replaced it in the right shape. That's not true anymore. C14 is also in those dinosaur bones because that original tissue has carbon in it, came originally from the atmosphere. So it has C14 in it. Dinosaurs, but supposed to be more than 65 million years old. Well, carbon 14 doesn't last anything like that long, but it's there, folks. In fact, C14 is found throughout the fossil record. Throughout the fossil record. That is widely known, has been for a number of years, is generally ignored. Slow decaying isotope dating, which is what you usually hear about is radiometric dating. We're going to look at some of these assumptions and problems with that nobody talks about. And then helium diffusion zircons, some fairly recent work. We'll talk about that a little bit. And then we'll talk about hot and cold blobs in mantle. That's going to be interesting. And while the scientific establishment is in denial about a lot of this stuff, basic bottom line is that they're going to have to throw out about half of their historical science, if not more, if they don't deny this stuff. Okay. All of this evidence is consistent with the young Earth. It says that the whole thing is thousands, not billions of years old. Questions and discussions will follow the presentation. So please make notes or hold questions to the end. Still other evidence is implying a young cosmology. Okay. This is same sort of thing is happening in every branch of science. The big thing that started the soft tissue found in dinosaur bones, it was in 2005. Dr. Mary Schweitzer. Schweitzer, I believe, she's a paleontologist at North Carolina State University. She's an up scientist and uniformitarian. So interesting, she is a Christian. All right, so she was first to get a big T-Rex femur and cut it in half and found material inside, and there was partly mineralized and partly not mineralized. And she chemically removed the mineralized stuff and leave only the tissue and found out that it was pliable and stretchy. It had the mechanical characteristics of the marrow in bones, including blood supply, blood vessels, red blood cells. And did more chemical work and found a number of different kinds of biological molecules, collagen and things like that. Real protein, things identified as protein, not rock. Now, all this stuff also decays fast. You know that. Take a blob of meat and stick it in a jar with some water and take a look at it a few days later. Doesn't last long. It decays fast. All right. So in 2006, after our work was announced, and an interviewer asked if it was amazing to find soft tissue and so old. Here's what Schweitzer said. It is very amazing. It is utterly shocking, actually, because it flies in the face of everything we understand about how tissues and cells degrade. Went on. A lot of our science does not allow for this. Or she's saying that that the way they understand these fossils and how long they last and how long this tissue lasts is opposites, total conflict, does not make sense. They can't figure it out. Since then, many suggestions have been analyzed with some theoretical models indicating that a million years with some preservation might conceivably be possible under ideal laboratory conditions. But it's always tied to ideal laboratory conditions. You have to exclude the bacteria. You have to make it sterile. You have to have just exactly the right chemicals and not the wrong. That's not related to what's going on out in nature. One of the things that's been proposed over and over is that the iron in blood acts like formaldehyde. In lab experience, the iron compounds in blood help preserve proteins by cross-linking them somewhat like formaldehyde. And this is been experimented with a fair amount, and it's real. Okay. Normally, tissue and water will decay into slimy mess in a few days. But when some iron compounds are added under ideal lab conditions, it will take 2 years to reach the same state of decay. So going from a few days to 2 years, you have to admit that's pretty impressive. It's a pretty big change. And that's the kind of thing that is thrown out. But here's what you need to think about. 2 years is still a long way from 65 million years. The age of the dinosaurs. Let's see, 2 years, it's what, 32 and a half million times 2 years, right? So really they hadn't made a very significant amount of progress toward that. It's a nice laboratory game, but it doesn't solve the problem in any way. Okay. All right, there have been some recent open access articles recent over the last decade on soft tissue that you can go access on your computer. You don't have to pay $32 to get a copy to read this one article in this professional journal, which is typically the case. Here's a couple you can access on the net. Okay. I guess this guy was a French or something. Fibres, of course, we would expect to say fibers of cellular structure preserved in 75 million year old dinosaur specimen. This is from Nature Communications. Nature's, the most esteemed journal, science journal on earth. It's June 2015. The author says, in part, exceptionally preserved organic remains are known throughout the vertebrate fossil record. That goes way back to the very early parts of life, when there when there were no land animals, it was just fish in the conventional evolutionary theory. It goes on. We examined samples from 8 Cretaceous dinosaur bones. This offers the opportunity to investigate relationships, physiology, and behavior of long extinct animals. And that's true. I can tell them a lot more about them than others, but he's not addressing the point we're interested in here. It totally contradicts what he thinks the age is. And that article does not. Does not explain how that can be. So here's another open access article. This is back 2011. Dinosaur peptides suggest mechanism of protein survival. This is in the STEAM biology journal. And they're saying that 11 collagen peptide sequences recovered from chemical extracts from dinosaur bones were mapped into molecular models of vertebrate collagen. This supports the hypothesis that the peptides are produced by the extinct organisms and suggest a chemical mechanism for survival. Well, it suggests that there is some chemical mechanism if they're sized that long, but they didn't discover what it was or provide for that. But they do know that these biomolecules that are being found, they can match them up to what's found in actual tissue. And a very substantial variety. So this is real, remains of real tissue, not just something that happened to look like it a little bit. Get right down to the molecular level, it's the real stuff. Okay. One suggestion has been ignored by the institutions over and over and over. Let's C14 test this soft tissue. C14 is radioactive. It's generated in the atmosphere, and it decays very fast. It decays to 1/2 of the original amount in just 5,730 years. So you can date this, use this to date things that have not been around more than or less than 100,000 years. That's getting beyond the precision you can do here with C14. Okay. But in anything like 1 million years, C14 is completely gone. There's none left whatever. So the presence of C14 tells you some real valuable information here. Okay. Since all of life is carbon-based and substantial amount of carbon that comes from the atmosphere in plants and animals. So C14 can be used to date, as I just described. And so here's a couple of dinosaurs that have been used, dinosaur eggs, and this is the famous huge T-Rex. And they have actually extracted some material from one of those thigh bones and tested it. And the half-life, it's 7:30. I told you that. I'm getting ahead of myself. It's difficult to measure anything above about 70,000 years. Here's where carbon-14 comes from. The cosmic rays come in to the Earth's atmosphere from outer space. Nobody understands totally where they come from, but basically they're protons of real high energy going real fast. They hit a nitrogen atom, and that changes the nucleus so that it becomes C14. The C14 is radioactive, so it decays back slowly. But in just a time span of 100 years or less, animals and plants and then animals are ingesting this carbon-14 along with all of the CO2 in the atmosphere. The carbon-14 combines with oxygen in the atmosphere to produce CO2. Well, plants love CO2. They breathe it in. They metabolize it. What do they excrete? Oxygen. Okay, that's what we need. So we breathe in the oxygen. The plants incorporate the oxygen into their material, their leaves and so on. Animals eat the leaves. They breathe the C14 too. So it ends up in everything that's living reaches an equilibrium condition with the C14 in the atmosphere. When they die, if they get preserved as fossils, then that C14 is there. It's no longer being adjusted. It's a fixed amount, but it's decaying. So if you can measure how much was there at the time the animal died, and then how much has decayed, then you can make a good estimate of age. All right. The dating process is often compared to an hourglass analogy. Looks like this. Here's the hourglass. Everybody knows that sand in the top compartment is falling through a little orifice or hole in the center that's very constrained, and that because it's constrained, that means a little steady amount all the time is falling into the bottom. So this is a model of radioactive material and is continuously decaying. The original radioactive material is called a parent product, and the decayed product is called the daughter product. So the top container is the parent isotope, and it's C14 in the atmosphere in this case, or ingested from the atmosphere. It slowly decays with a half-life of 5,730 years. The daughter isotope is N14, and it's in the atmosphere. Okay, so we can measure how much if we know how much it started with. Then we can measure how much is still there and make an estimate of age. The way it decays is represented by this graph. The red curve here is how much of the material has decayed in any point. The horizontal scale here is in half-life. So one half-life, it goes down to 50%. Second half-life, down to 25%. Third half-life, it's like 12.5%, and so on. So each increment. All right. So that's how this process works. Let's look at this same kind of graph with actual time down here in the case of carbon-14. So where it's 50% here, it's 5,730 years. But we can read off 10,000 years at about 30%, about 10% about 20,000, so on. So here's the scale. When you start getting out here it's changing so little that it's really hard to do anything with it. So this is the part of the curve they use is out here, not out this direction. Okay. All right, let's look at some of the work that's been done measuring these dinosaur bones. Here's some of the earliest data that was produced and they're using the top professional radiometric laboratories. They're not doing these experiments as such. They're collecting the samples and they're sending it to the top laboratories. Okay, so we got a couple of triceratops here. And they come up with ages of 30,890 plus minus 200 years. Some hadrosaur samples, and they coming up with 20-something thousand years. An Allosaurus, Archocanthosaurus. These guys ain't touched it. They're like the 20 and 30,000 years. It's not millions of years. It's not 65 million years. A couple of tens of thousands of years. Okay. So that's hard to explain. How can this be dinosaurs? All right. Here's some more recent work of the same kind. Going out and looking for more dinosaur bones with soft tissue in them. And here they come up again. Here's some Archocanthosauruses, 20 and 30,000 years, and Allosaurus and Hadrosaurus. A number of different samples here. Some of these dinosaurs, I took several samples from. That's good science practice. Again, here's 33,000. Here's 1,950, and everybody agrees that's a contaminated sample. Something wrong with that. But the rest of these are 20 and 30,000 years. All right. We'll look at some more data that has been produced. This is C14 and fossils and coal. Now, these guys, which is the Creation Research Society, they have plotted the amount of the C14 age on these fossils and coal with the ages given down here in parentheses are the conventional age of the strata that it was found in. Okay, so the conventional scientists say, well, these are the ages, and these run from, on this end, this is 10 million here and 30 million, 45, 50, and 6, 7. In other words, they've been ordered increasing out here. Out here on the end is 505 million. 505 million. That's back early in the Cambrian. Okay. You know, it's all these sample values, all of them come in between 20 and 60,000. Okay, most of them water around in here in the 20s and 30s and 40s. This is not just dinosaurs. And it's not just 65 million years ago. It's the whole gamut of life. The whole thing. So this goes a lot further. That's important. Okay, so it's there. It's all over the place. It's just not an isolated case here and there. The really strong trend here. Yeah, we ought to go out and gather more samples and test more and more. But this is a real strong trend. You can't just dismiss this. Not rational. All right. Here's some more C14 data. This data was collected by Dr. John Bongard. He collected this from secular research journals. And this is C14 in not so much in soft tissue fossils, but in many kinds of rocks. A lot of rocks were once living material. So this has been ordered from this column is in percent carbon 14, percent of the carbon 14 taken as a percent of what's currently in the atmosphere. Remember, the uniformitarians say that whatever we measure is now, then that same thing's been happening in the past. So they say if you have C14 in the atmosphere now, it's been more or less constant in the past. All right, so they're always comparing everything to that. So here's their evaluation. Here's the amount of carbon, percent of carbon 14 as a percentage of what's in the atmosphere now. The range it gives is from 40 to 75,000 years. That's the interpretation of the carbon 14 data. Okay, the top up here would be 40,000, and there's several pages of this. Okay, so after 4 pages, you get to the bottom, and you went from 0.7 to 0.014 down here, and that would correspond to the 70,000 years. There is graphite in here. There's some wood that was found in some, go back and look at. There is marble, natural gas, natural graphite, fossil wood, marble, anthracite up there, which is high-grade coal. It just goes on, all these different kinds of rocks that contain carbon. All those pages, there's 90 samples on it. Yet this stuff goes back into some of these graphite samples are in the Precambrian. That's before life existed by the usual way of thinking. Yet they're saying, no, it's not more than 540 million years old. It is in the range of 40 to 70,000 years old. All right, let's look at that from a geological perspective. This is a cutaway of, this is the Grand Canyon here, and this is what's known as the Grand Staircase that goes up through Utah, okay, northern Arizona and Utah. This is some of the greatest exposure of geology on Earth. Right in here, some of the most complete geologic column that there is. Though there's some gaps in here that they don't mention. There's some strata that should be there that's not. But this is one of the most complete geologic columns on Earth. So what those recent data is showing is that all throughout all of the strata is C14. C14, which cannot be more than 70, 80,000 years old. This bottom line here is a discontinuity called the Great Unconformity. Life started just above this in what's called the Petite Sandstone. Below that is just bedrock. It's metamorphosed bedrock. And then you got what was originally one layer after the other over extreme distances. This is 150 miles here, but going east and west, and well, I'll show you. It is utterly amazing. Okay. Well, click on that. Finish. Okay. But wait, what about the slow decaying isotopes? The uranium, the strontium, the potassium, argon, and others. Half-lives are but a few billion years. I put the but in there somehow. It's not there. Half-lives are a few billion years. The half-life of uranium is 4.5 billion years. So it can last through all that strata. And that's what they're usually measuring to make the age dates that would say that the bottom of that strata is 540 million years ago. And it gets younger and younger as you go up. This is what they use. So let's look at this a little bit. Didn't we pay attention to this? Doesn't dating by slow decaying isotope prove the conventional ages of the geologic column? Conventional science would say yes, it proves it. Okay? That's long thought to be true and unquestionable in conventional science establishment or where your kids go to school. So let's look at the decay process a little bit. Again, we use the hourglass analogy and pretty much the same way. In this case, the parent isotope in the top of the hourglass is uranium-238, for example. Slow decays with a half-life of 4.5 billion years. Okay, the daughter isotope, after it goes through a number of different steps, final stable isotope is lead. Okay. All right, let's look at this graph. It's exactly the same as before. When you look at it in terms of the number of half-lives. But here, the half-life is 4.5 billion years, where with C14, it was a little over 5,000 years. Okay, so this would be great for testing very long times, and that's why they used it. Okay, but there's some hidden assumptions. In fact, there's 7 unknown variables involved in radioisotope dating. These are actually in the equations that they make tests and they get values and they plug those values in the equation. And they have to come along, they have to make some estimates of some things to stick in that equation, or they can't turn the mathematical crank. Let's look at what You have the parent isotope again. What's the starting amount? You weren't there to measure it. So you have to make some kind of guesstimation. Okay. Slowly decays half-life. Well, maybe we can measure that some reasonable estimate now. Okay. It's reasonable to say, well, maybe it's always been that way. Maybe, if nothing too unusual happens. And the daughter isotope. Again, we don't know what the starting amount of daughter isotope was. It's generally assumed that it was 0, but that's not necessarily true. That's the easy way out. All right. But there's some more too. During the billions of years that this is decaying, there could be some material coming in from the outside, either parent or daughter. There could be some lost from that process to the outside. And there's no way to determine this. Most of these rocks are fairly permeable. And most of these chemical isotopes, chemicals for which we're talking about the isotopes, they are chemically combined in salts. That is, that they're very soluble in water. And they can be moved around with water that is filtering through the porosity of the rocks. And it does happen. So these are the 7 assumptions. These aren't the 7 knowns. These are 7 assumptions. This half-life might be reasonably known. But that leaves the rest of it. Okay, let's look at it a little bit more. There's a lot of evidence that these things are real problems. They're not just theoretical ones. We'll look at 2 of these, volcano magma and special geologic circumstances where we can tell what the relative age is from the geology. Okay. In 2007 edition of The Young Earth by Dr. John Morris, my favorite authors, he published this list of volcanoes and the dating of those eruptions. Okay. In the known age column is when we know or have good evidence of when the eruption took place. And values range from 17 years to something less than 1,000. Okay. Me, I would know exactly because they were there to watch it. Okay. But many of them, like this first one up here, I'm not sure how to pronounce that. Oh, say that again. Walla. Okay. Okay. 200 years ago, in fact, but the isotope, the slow decay isotope dating came up 1.6 million years in one case, or 22.8 million years in another case. Not only wrong, it's not even consistent. Okay, Mount Etna in Italy. Various times it comes up consistently with something in the hundreds of thousands. That's way wrong, and it's not terribly consistent. Sunset Crater, 950, 270 Kilauea, something less than 1,000, and it comes up with 43 million, 30 million, 21 million. Pretty big era. Kilauea, Stromboli, so on. There are a lot of huge eras here. Okay. So something about the magma there. Then there's a situation where out in the Grand Canyon where the basalt lavas from a nearby volcano out in the western part of the Grand Canyon actually the lava flowed down in the Grand Canyon, actually built up at the bottom and dammed it up for some time. And the river formed a lake behind it, popped over it, and got a channel down through it again. And that has happened several times, in fact. Okay. All right, let's look at that situation a little bit. Here's a diagram. Cut away the Grand Canyon again. Here's the peat sandstone right above the Great Neck Conformity here. And the red wall limestone and so on. And this is the area that's on the north rim of the Grand Canyon, way out on the western part of it. Volcanoes flow down in here. But notice that it dammed at the bottom. Notice that this is on the top. On the top up here, it's on the top all the way down here, it's on the top of everything that's down here. So that means it's the most recent thing in the Grand Canyon. It's young. Everybody, all geologists essentially agree that the Grand Canyon is well under 1 million years old. So this has got to be way under that. It's the youngest thing there. Okay. Well, this is perfect situation to date this material. And it has been dated by the professional geologists a number of times. Here's some of the data they come up with. Potassium argon model, they come up with anything from 10,000 to 17 million. There's 5 rubidium strontium model ages. That's the old standard. Take one sample, make an estimate from it, make a measurement from it. Comes up with 1.27 billion or 1.39 billion years old. Then there's the more sophisticated isochrone method that uses an array of samples. This method is supposed to cancel out a number of its own errors, number of possible errors, okay? But you get the same kind of answer or worse, okay? So this all confirms that this is something on the order of 1 billion years old, 1 or 2 billion years old. But the geologic situation here says that this is maybe 10,000 or a few tens of thousands. Okay. All right. You go down here, this intrusion down here they call the Cardenas basalt. You get pretty much the same sorts of things. Of course, these both probably came from the same magma chamber down below somewhere. Okay. All right, well, that raises a lot of questions. How can these isochrone dates be so wrong? Dr. Steve Austin once wrote a number of the leading isotope dating experts in the world and asked them, well, what's going on here? Your stuff's not working so great. How's this happen that way? And they each came up with a different mechanism. One of them came up with partial melting in the magma chamber. Since different minerals melt at different temperatures, as it heats up or cools down, then they can get separated. And so you can get magma comes up with it's missing what it originally had or pick up. Also, there's melting of the surrounding country rock. When the magma comes up from magma changer through some channel toward the surface, it's melting stuff along the sides all the way and get contaminated. And that'll change even both of those, in fact, all three of these will change even the isochrome method, as sophisticated as it's supposed to be. The third thing is inconsistencies in the mantle source in the mantle of the earth down below. The uniformitarians say, well, this is, it's been circulating slowly for billions of years. So it must be well mixed up. And it's all homogeneous. It's all the same. But things like this say, no, it's not. And a number of measurements of magma at mid-ocean ridges show that it varies quite widely. So here's three things that change those readings and are responsible for the errors. But wait, all three of these factors are always involved in various combinations everywhere magma is coming up. Everywhere. You can't have magma coming up without involving all three of those in some degree, but you don't know how much of each one or what combination. So this kind of dating can never be accepted without serious questioning, without quantifying how much the above mechanisms are affecting the result. They don't have a way of doing that. Okay, so from the geologic strata, we can see that fast decaying C14 at all levels in the strata. So always lay down thousands of years ago, not millions or billions. Even for a worldwide flood that reworked Earth's geology. Okay. This Pete Sandstone. Here's our same diagram again, covered by the Grand Canyon, and here's the volcanoes. These are sometimes known as Vulcan's throne. The Pete Sandstone here on the bottom, right above the unconformity. Many of these strata are extremely extensive. Here's where the Pete Sandstone occurs in the North American continent. It's perhaps half the continental area. Furthermore, it goes over into Europe, down through the Mideast, across North Africa. More recently, it's being found in South America. This is absolutely a worldwide event. Let's take a look back at this picture again of the strata in the Grand Canyon. This Pete Sandstone is all the way across there and all across half the world, it seems like. And it seems like the trend is toward the world. This is a world-scale catastrophic event that ripped up what was there before, moved it around, and started laying it back down over very large areas in a very uniform way. It was water that did that too. We don't see anything like that going on today. So the uniformitarian approach to try and interpret everything in terms of what we see going on today is just hugely flawed. Okay, let's go ahead. Some of these divisions between these strata there's like it's a knife edge, and it's a knife edge for hundreds of miles in many directions. But there are other ones, and what the geologist line of thought about that is, well, there's a lot of erosion, and that root then start laying something down, and then that causes that kind of immediate change in the strata. But then there are other cases, and they say that there's a big time gap where you see that for a lot of the time that they're saying. But you see situations like this. This is the Moab limestone and the Redwall limestone. If I can look at that picture. This is the Redwall limestone down here, and the Moab is that. Okay. So when we look at this, we see Moab limestone alternating with Redwall limestone. And this is interfingering, sometimes it's called interdigitization. And that geologists take a situation like that to mean that there is no time gap, that's a continuous change from one to the other. So here's another one that contradicts what the standard line of thought is. Okay, here's an interesting thing to be aware of. Back in the 1980s, other people became aware of it then anyway. Dr. John Baumgartner, interesting character, is originally an electrical engineer. And he earned his master's degree in electrical engineering at some school called Princeton. Of course, it is one of the most highly esteemed universities on earth. And he got to learning about creation science, and he began to realize, as hopefully some of you are, is that there's a lot of good science to this. And he became a serious Christian and found himself praying, well, Lord, how can this be revealed to the world? Why can't serious research be done? Why can't modeling of a flood be done? And he kept hearing this little voice in the back of their mind and said, oh, what about you? And so he eventually started taking that seriously, and went out to University of California and entered and changed his major to geophysics. He earned a PhD in geophysics. And as he was doing that, he did some important work on mathematics of simulations. What we now know is certain kinds of finite element analysis, doing it in compact and efficient ways. And he got to the place where he could do extremely large scale, like the whole Earth. But he didn't have the computers to do it on it. At that time, a little institution called Los Alamos National Laboratories got interested in him. And they liked what he was doing so much, they gave him a deal like name your price. Come work for us. And most people would expect him to name a big fat salary, which he could have gotten. But he said, no, I want to be able to spend half my time and half of my computer usage simulating a noise-gen flood. Now, these research institutions are mostly just radically materialist. But they wanted him so much that they agreed to that half his compensation was the use of their computers and half of his workday. They probably actually had to do batch jobs overnight. But Baumgartner ended up creating a program simulating the whole Earth mantle geology, all of the physics involved that anybody can know anything about, and running it on Los Alamos computers. That's a God thing that happened there. Well, here's just a little a snapshot of some of the simulation. He ended up starting with a Pangea configuration, what geologists say things were like 200 million years ago. And at that time, all the continental material was assembled into one giant continent. And later on, it started breaking up and separating in North America, South America, Asia, and Antarctica, and Australia. And his simulation showed the same thing happen. The physical forces of a certain situation generated that same separation. And this picture we're looking at here is kind of midway in that process, where you see a piece of Pangea broken off here. It looks a lot like Africa. And this piece over here is North America, and this will become South America, and they will separate the positions. This piece here is India, and it will sail over here and smack into China. And Australia will sail down this way, and Antarctica down here, just like it really is. This yellow and red is the exposure of metal that will have to cool. Okay. We look at the next slide. Now, this is into a simulation. The simulation time on this slide here is 50 days. Halfway gone from one continent to the breakup we know today. 50 days. Maximum velocity, these arrows all over the place of the velocity is the continent of the material involved. Maximum velocity is a meter per second. Get over a meter per second. That's 1001, 1002, 1001. Yeah, continents are moving along like that. Many places. So in a year, and by the way, all this has been submerged largely by water being displaced by where it's hot, it's rising, being pushed up. And that's displacing ocean water all over the place. This next view is a cross section. In places where the continents move on the leading edge of that. It's hitting the ocean floor plate, and the ocean floor being denser, it has to go underneath the continent. It shows exactly that going on here, and that ocean floor plate is being pressed and pushed down, and then it gets down to the sphere's discontinuity down here above the, I believe that's the 660 discontinuity, and starts piling up there. Hot places show some here. This is just beginning to get good separation. It continues a lot more. So that process goes on, and it motivates the flood. It is the cause of the flood. It's why the water is moving around on scales that floods the entire continents. And again, much of the scientific community, when the stuff was published, said, "I can't be. We know better than that." Well, about a decade ago, some geophysicists have been able to tomographically examine data throughout the mantle fairly successfully. And they have found that the velocities through there, various parts of the mantle, indicate that some parts are very much hotter and some parts very much colder. And it's something on the order of 1,000 to 1,500 degree differential. And it's right where you should find subduction. The cool parts of the blue in here, like this subduction here, and the hot parts are just where lower mantle's been pushed up higher. Well, the farther in you go, the hotter it is. This is basically a smoking gun. This says that the cold plates going down and the hot mantle being pushed up is actually there. And furthermore, it should be expected that if this had been 100 million years old or stuff like that, that this was all gone to thermal equilibrium with the rest of the mantle by now. Again, it says it's young, and they don't want to talk about that. Wherever you find talk about this, you'll find them talking about the velocities of the pressure weights, the P weights. And they're very reluctant to talk about the temperatures that implies. Okay. Oh, I was looking at one panel and I didn't show you that. All right, so here is the red part where a mantle has been pushed up. I can keep my finger off part of the mouse. The blue part is the subducted panel, just like subducted ocean plates, just like this blue here. Okay, and this blue. Kind of two on the opposite side. And there's a separation here and here because of the discontinuity. What is it? 440 kilometers, and another one at 660 kilometers down. This picture is so much like what's supposed to be going on here that it's just like a smoking gun. And because it's still hot and still cold, it cannot have been happening 100 million years ago. All right. More recently, have been able to, here's a subducting plate. This is Tonga plate down here on the world geologic map. What is remarkable about this is that this blue core, it doesn't heat up as it goes down. It should get thinner and thinner with this light blue part, becoming water more and more deeply, where the cold plate is heating up as it goes down. But it doesn't show much of that. Way down here at the tip, you do see some of that, where that light blue area is getting wider and wider, and the center dark blue is getting narrower and narrower. But most of the way down, it's not doing much of that. It's not heating much. That means it cannot have been that long. They've done this just many places over the earth. Okay. Let's see. Excuse me. Throat's got a little bit dry. Here's another topic that we'll say just a little bit about and give you some resources. About a decade ago, a number of scientists, some from the Institute for Christian Research, some from the Christian Research Society, got together and said, we're going to learn more about this, about the way rocks behave and cool and how the radioisotopes are distributed in them. And they got studying the zircon crystal. Zircon is an extremely hard mineral. It has the highest melting temperature of any of the minerals. So when the magma starts cooling off, and the zircon is the first thing that solidifies. And it happens to have a chemical affinity for the uraniums and thoriums. So it practically sucks them in as it solidifies and captures them. Because it's chemically bound in this very hard mineral, it creates practically an ideal isolation. So the way it decays in zircon can be studied pretty reliably. Okay, so they developed models of it, and we recognize that as uranium decays down to lead, it produces 8 helium atoms in the process. Well, helium's an inert gas. It doesn't chemically react with anything. It's a real small atom, okay? So it diffuses through things very well. It's about the only thing that can get out of zircon. Okay, so if we can measure how much decay products are in there, then we can know how much helium was generated, and we have both the diffusion process out. So diffusion is a well-known process. There are excellent mathematical models of it. So these scientists modeled all of that. And this has never been done. It had never been measured how fast helium diffuses through zircon before. So they use this as an opportunity. They made 2 models. they made one model, which represented by these green lines here, that assumed that the diffusion must have taken place in the young Earth's creation frame, or 6,000 or 7,000 years. And to get on the vertical scale, we have the rate of diffusion. Okay. On the horizontal scale, we have temperature. These scientists use inverse temperature here, but it's the same. It means temperature. Okay. Now this red curve down here, he makes the uniformitarian assumption. And they say, well, if this has been going on for 100 million years, then it had to be very slow diffusion, very low amount of diffusion. So that's why the red line are down here. All right, now they sent the zircon crystals they had extracted from granite. Half Dome up here is a good example of granite. All over, all the Sierra Nevada mountains are granite and so on. So the granite they used is actually from New Mexico. But they sent out and said, all right, measure the diffusion rate of this of helium in these zircon. And wanted to see what model this would fit. Of course, they did this through a third party so that the laboratories could make these kind of measurements, would not be prejudiced against the creationist organization. So they did through a third party company that it would be reasonable for them to ask something like that. Well, here are these black balls of the data they came up with, that the world leading expert in this field came up with. Notice that it all fits the model for the young Earth. None of it fits anywhere close to the model for the old age. You see that? In fact, the difference is a factor of 100,000. So how can it be that it? In fact, the high temperature values are easier to measure, so they did all the black balls values there. Is that, well, we really need some lower ones too. And they say, yeah, but that costs a lot. That takes a lot more time and costs you more. So more. So they cost us the money and got the measurements made. That's these green ones down here. All right. So the point is, the actual measured data fits the young Earth, not the old Earth. Okay. A lot more needs to be done along those lines. A lot more samples from different places. And so. The most available approach for science is the examination and testing of multiple contrasting models, not just one favorite one. With data like this running around, it's high time that scientific institutions start using a two-model approach, not just one favorite one that well, we know. Well, you don't know. Here's a lot of contrary data. Okay. Same thing's true of our churches, of course. When Scripture does not tell us very specifically what is true, we should examine and test multiple contrasting models to be open to new understanding. Sure. We should, along the way, we should remember the Lord's command to his followers. John 15:17, for example. This I command you, love one another. Go read the context. He didn't say any ifs, ands, or buts about it. He didn't, not a suggestion. Man. Okay, there's similar things other places, so might check that out sometime. Here's a couple of resources. Thousands, Not Billions, is the title of a book written by a member of the rate research team that I was just speaking about, Dr. Don Young. He's a PhD nuclear physicist. He teaches undergraduate students, physics students, in a Christian college. So he's real good at explaining complicated things. People are not real sophisticated yet. It's a tremendous book and addresses many of the things I've talked about here. Dr. Don DeYoung, thousands, not billions. If you want on the rate projects I was just speaking about, you want all the technical details. If you're a scientist or an engineer or something like that, you want to know what the math is, what the methodology, what they did in the lab, and so on. Now, here's 800 pages of that. It's different chapters written by different members of the rate project. It's available at icr.org, at creationresearch.org, or of course at Amazon. So this is a tremendous book for the scientifically trained. Another thing is a recent Darius Quarterly issue about the IDINO project, IDINO, where they have been doing soft tissue research. Okay. They've done a lot of original biomaterial in fossils, soft bone material from horn of a triceratops, dinosaur tissue and bacterial biofilms, dinosaur peptide preservation and degradation. A lot of this comes from the famous Hell Creek formation. They've done a lot of radiocarbon in dinosaur and other fossils. Tremendous stuff. A number of articles in that issue. I didn't write down what issue it is. A little bit disappointed. But there's one more. But wait. C14 dates 20 to 40,000 years, and that's not consistent with the young Earth either. We're talking about less than 10,000. So what about that? The answers in the assumptions being used. The uniformitarian assumption says that near constant C14 in the atmosphere, but you can't go back 1,000 years ago and measure the C14. Creation and flood geology assumptions are that a sharp rise in C14 during catastrophic flood due to die-off of a very large biomass in the flood. Before the flood, there's probably a much larger biomass breathing in oxygen, breathing out CO2 than we have now. When you had the flood, it killed all of that off, except what was on the ark. After that life began to regenerate after the flood, began using CO2 out of the atmosphere again. But until that happened, the cosmic rays, if they were constant, generating the C14, then it would build up faster in the atmosphere to a higher level than it was when you had a very large biomass. Well, here's some graphs that show you that. A little exercise for you engineer kind types. On the horizontal scale, we have years before the present. On the vertical scale, we have percent of today's carbon in the atmosphere. We have three sample values hypothetical sample values, a smaller one and a middle one and a larger one. We know what all of that is in the present. We know that since that's a exponential decay process, that each sample has a decay curve attached to it. This one for that sample 1, this one's sample 2, and this one's for sample 3. That's just the plain physics. That's in every physics textbook. The uniformitarians assume that today's carbon level was always there. So when they work the equation, they take the curve for sample 1 and they extrapolate back till they get a value that's equal to the assumed amount of carbon-14 in the atmosphere. And that occurs at a particular time. And that's the date. Okay, so their value for the date comes as much for the uniformitarian assumption as it does the actual data. That's the key fact you need to understand. Each decay curve where it equals the assumed data gives a different date. And this is this hypothetical example. This curve gave 7,575 years. This intersection gave 19,000. This intersection gave 9,000. You say, well, that doesn't fit a young Earth flood, which was maybe something over 4,000 years ago. Here's the key. This assumption. What if that assumption is not true? What if we had at the flood C14 rising to the present level due to that huge biomass being killed off at the flood? And then we would have a curve like this for the atmospheric carbon-14 after the flood. Before the flood, it would have been a value like this, and all biomass is killed off. And after that, C14 rose until a new level of equilibrium with the sample. So, if we follow this curve back till it intersects with that curve and comes down here, then it's something right after the flood. If we follow this curve back to where it intersects that model, then we get something just almost immediately after the flood. If you expand that out, it just works beautifully. The thing I want you to see, the result is strongly dependent on the assumptions you make. You make an assumption, a uniformitarian assumption that's consistent with old age, you get old age financials. If you make a model that is consistent with what the Bible tells us about the flood, then you get everything working together in the flood model. The assumptions are all important. So I say build assumptions on the Bible information. Okay, well, that's kind of the last point. Here's the conclusion. The present is not the key to the past. That's what the uniformitarians say. The flood is the key to the past. That's what the Bible. All right. One more point to make here. Dr. Edward Larson, professor of law and history, at the University of Florida, back in 1999, did a scientific survey about what the scientists believe. Okay? There wasn't a whole lot of information. You go digging, it's hard to find out. What do these scientists really believe in a religious way? Okay? The big question he put to the survey participants, and this was a rigorous scientific sample of all scientists, and a random sample taken from a book like Who's Who in Science. So these are all professional scientists. He asked them, do you believe in a God that answers prayer, in an afterlife, a God that guided evolution? So he's asking 3 key questions about it. Are you a serious theist, Christian theist? Maybe Judeo-Christian. Okay. All right, so here's some of the results he got. The broad scope of all scientists, 40% of them agreed with those 3 statements. Okay, 60% did not. So I always thought it was kind of surprising that it was that many. You would think we'd hear from them, didn't you? All right, he went and did another step in this survey. He sampled the National Academy of Sciences. This is the scientists at the top of all the institutions. These are the scientists that do the peer review, decide what gets published. These are the scientists who control the funds, decide whose research gets funded. These are the scientists who head the institutions and decide whose career moves to higher position, gets career advancement. The National Academy of Sciences, only 7% agreed with this 3 questions. 93% did not. So this is what's controlling things. This 40%, if they speak out and tick off this 93%, you know how far their science career is going. It's an interesting fact. The National Academy of Sciences, they elect their own membership. So naturally, they don't vote for people that are opposite-minded. They don't vote for, or they vote for people who are like-minded. So this materialist kind of attitude at the top gets entrenched. Kind of a good old boy club. And they invite like-minded people to be in their in the National Academy of Sciences. And then they get to control everything. Anybody that doesn't like being a materialist better keep his mouth shut. Or stay in the closet. So that's what's going on in science. And that's why, to a large extent, all these evidences I'm presenting to you just are denied. They won't talk about that. They won't give it any consideration. They won't give it any research funding. They won't give it any publication. That's what's going on. but onward, trusting in God. All right, review. Evidence we have seen tonight. There's soft tissue and lots of dinosaur bones. And the more they test, the more they find. The more they forget that they know it's not there and test it and actually do the testing and find it. Same thing with C14, the C14, that soft tissue and in the dinosaur bones. All throughout the fossil records, not just dinosaurs. C14 throughout the fossil record, throughout the geologic column, slug decay isotope dating. We see that there are 7 assumptions, and we see that they're very important. You can't ignore the assumptions. We see helium diffusion in zircon says that even the granite plutons, a lot of mountains made out of. Those things are not billions of years old, or hundreds of millions, or even millions. We see hot black cold blobs in the mantle just seem to very much confirm what John Baumgartner has been doing. And he said that the flood completely changed Earth's geology, remade it, reworked it. And we've seen why the establishment, scientific establishment, is in denial. Our opponent group of materialists are in control. That's why. And they're not willing to look at that one. They're not willing to follow that one. So, questions? Yes, sir. As I recall, they were saying they agreed to all 3 of them. It was one question, 3-part, one question that I believe is a yes or no answer. Well, the God-guided evolution is absolutely contrary to the way evolution is taught. Yet, evolution is taught in all the universities, in all the schools, to be a completely random and purposeless process. Okay? No purpose or of any kind involved. That says no God. Okay? But yet, Larson survey says that 40% of the scientists actually say, yeah, we believe that it was guided. If it's guided, you got to have a guider. Absolutely. But it didn't happen, and it did not happen in the same way that it's taught by the uniformitarians. Okay. Mm-hmm. There's a yes, a part of that question, part of that, and there's no part of it. The little bitty changes, we do observe them going on, okay? But the changes from one kind of organism to another kind of organism that's got different kinds of organs, it's got different body structure, this kind of thing, that's called, often referred to as macroevolution. And no, that didn't happen. Those are created kinds. That's a big subject. But yes, you're right. Okay. By the way, next month's presentation will be about the first occurrence of the first cell, first life. How did that happen? I am. And I'm going to be using a Discovery Institute DVD as an aid. Okay, very interesting, very powerful, very important. Okay. Okay, where are you seeing that? Yeah. Okay. Let me comment on that. Okay. I don't know those names, but when you have a presentation like that, it's just stated, you don't know what perspective they're coming from. So, they, okay. Uh, they could also be old Earth creationists and still say all those things. So need to be a little bit careful. This could be Hugh Ross's group, for example. I don't know. But yes, ma'am. When? Okay. They didn't consult me on that, so I don't know. That let me make a note of that. I need to check that out. Mm-hmm. Yes. Uh, did anybody see is Genesis History movie? What did y'all think of it? Pretty good. Very informative. Okay. Informative. Okay. So, of course, is Genesis History interviewed a number of creation scientists, starting with Dr. Steve Austin, who is a PhD geologist, arguably the most important geologist in creationism. Then Andrew Snelling, Dr. Andrew Snelling, and he's a hard rock geologist. Uh, I've taken courses under both of those guys. Wonderful experience. And there were a number of others. And it will be out in DVD sometime in April. We will, at some time in the future, review that film because a lot of people didn't see it. DVD form. We'll stop after each interview and each teaching by these guys, and we'll discuss what he said and kind of and give you a chance to talk about this some and get it ingrained in your memory. That'll be good. That's something I'm thinking about in the future. Other questions? Yes. Yeah, yes, I have found red blood cells. Something. Uh, well, should. Here's the interesting thing about red blood cells. The red blood cells circulating in your bloodstream don't have a nucleus. It's an interesting fact. But reptilian blood cells circulating in a reptile bloodstream do. still retain their nucleus even after they got out of the bone marrow. All right. Now the red blood cells that they found, that Mary Schweitzer found, have a nucleus. So they're reptilian. It also proves that it wasn't some human blood that contaminated the sample. All right. Yes. I don't know how much the Earth's magnetic field is going to affect cosmic rays. Uh-huh. There has to be some interaction there, yes. I'm not sure how much or what way it's on. Okay, and for particles of lower energy, there is a lot of that, like in the bursts that come from the sun. That can be pretty dangerous stuff because there's a huge amount of that compared to cosmic rays. So they're lower energy, and it would affect those a lot. Go ahead. Also, very unique thing. Carbon dating the topic. Something like 2005 is still having carbon dating any topic. Don't have the exact date, but somewhere around there between 2003 and 2007, still haven't done it. ICR was pulling their hair out trying to figure out a way to get any of the labs to test samples to do the test because the labs were refusing to run the test because they knew that the soft tissue was going to come out as carbon-14. And so there's a lot of stories behind it. As I recall, what they had to do was send it anonymously to a bunch of labs that were recognized by the national scientists. NAS is a number. They simply sampled several NAS labs, and then that came back showing it had radiocarbon. Let me straighten out one thing for you, folks. The labs aren't owned by the NAS or something like that. Okay, let me finish, please. I'm just trying to correct that there are a number of institutions that have labs that just they are run like a business, and no, I'm not trying to. When they refuse to date something, when they know, hey, there can't be any C14 in that. You're right, they have done that. It was a big problem, but I can't pin that blame specific on the NAS. That's the only thing I'm trying to do. Yeah, they were big concerned. Absolutely. I think many times people want to do this kind of testing, still go through some kind of third party or something like that to kind of, especially if it's a creationist organization. Okay, they'll probably all go through a third party. Now, Mary Schweitzer, if she wants to do it, then she doesn't have to worry about that. Now, early on, she may have, but not now. Mm-hmm. Okay. David. Well, I'm not fully knowledgeable to answer all your question like that. Many places things are exposed where they don't have to drill down. Where they do drill into coal seams or things like that, coal is a major source of material to test C14, and it's always there. And another place where they drill down is only petroleum-related hydrocarbons. Also have C14 in them, and natural gas and so on. But okay, more specifically, what are you talking? Example. Not that I know of, but I think there are some cases in the world where yes, there has been Precambrian oil found, and there are some major scientists that have theories that that oil and related hydrocarbons are generated by a bacterial process, really deep in the really not deep in the mantle, but deep in the crust. And I don't know too much about that, but I do know that that kind of theory does exist. It's not well accepted, though. That's a typical line of thinking. Mm-hmm. All right, let's see if we can get back to one of those. All right. All right. All right. This stuff is metamorphosed sediments and granite and reheated and crushed up, and so no telling what was really there before. And the thing I can tell you is that in these captured parts where you have blocks that slid down, this is probably Precambrian material that was before any of the rest of this was generated. This is some of the strata that was there before whatever wiped things out and formed the great unconformity occurred. Now, it is true that in some of this there is graphite that has C14 in it. Precambrian graphite has C14 in it. That means it's young, yeah. Yeah. Precambrian means more than 540 million years old in the conventional view. It's still got C14 in it. That means it's got to be less than 70,000. Okay. Mm-hmm.
Every diamond has something that the right like 90,000, equivalent like 90,000 years.
Yeah, every diamond that's been tested so far. No.
One of my expectations was that there was going to be a continuum on ages. Before when I think that New Testament method, probably 15, that there was something progressively to find older and older specimens. So there's kind of a band, like you said, between 30 and 50,000 years. All other things.
Mm-hmm.
And then there was nothing because it got out to this graphite and diamond, which was 75 to 90,000 years old. There was nothing in between. That was some evidence of flood. There was a big gap between the two.
Mm-hmm.
I know where you're going with whether there's stuff below there under the phone. I don't. There's an ICR's website and Google oil or food form. There's like a 30-minute audio lecture on that. And oil is made from plankton. It's buried, has been buried between about 15,000 and 15,000 feet of rock. But it has to be buried for about 200 years under that much pressure. It takes something like 200 years to shoot to the surface unless it's natural crack. But it would go. Anyway, it's worthwhile to keep that, watch that. Oh, they also mentioned that they actually were able to duplicate this in a lab. From the University lab in Oregon, they were able in 2 hours to produce 3 plankton. Basically, artificially replicating it at the number of.
Okay, let me squeeze in a couple of comments. You're talking about the artificial generation of oil. Same thing's true of coal. Both of them, all of those kinds of products can be generated in laboratories under right conditions quite quickly. It doesn't take millions of years. It takes the right, correct chemical conditions. Chemical and physical conditions, and it can happen quite quickly. And some of them, if I recall correctly, it's on the order of a few hours. Okay, so well, what do you think happened in the flood? Mm-hmm. Want to bring us a report on that? I know. It'd be nice if somebody could look at that and bring it back. I need some help. I'm looking for some more help, not some more things to do. Okay, so yeah, you're right. There are a lot of reports of laboratories that have found the optimum conditions and bring about these coals and oils and things quite quickly from biological materials.
right book that you put up there. Going through as much as 800 pages this time. One of the things is the pay rate, the half-life. Apparently, that's about something. So you measure the half-life based on ambient. They have the problems this quarter today, where they have pretty different long age artificial methods. And taking into account the margin clear, none of them overlap. So either 2 or 3 or all 3 of them have wrong. But then you elevated temperature, be able to convert with a younger version of a resolution.
Okay, well, it's about 9:30, so let's unless somebody's got one more burning question, then better call it tonight and enjoy some fellowship and some refreshments, and come back next month and we'll talk about the origin of the first life, first cell, and what a problem that is for biology, and it is very, very interesting. So, see you then. And